Okay, let's try another problem. And in this problem, it's basically two parts. Let's read it so you can see what I'm talking about. It says a compound is found to contain 68.4% carbon. It's containing 13.9% hydrogen and 21.6% oxygen. And we are looking for, here's our question word, what is the empirical formula for this compound? Empirical formula. So we have to dig back into our memory banks and we have to calculate the empirical formula. And there were 3 steps to that. And the first step was to write down your percentages, 68.4%, okay, for carbon. And we have hydrogen at 13.9%. And we have oxygen at 21.6%. And the first step was to change the percentages to grams. And it was very simple to do that. We're going to take the percent off, and we're going to change it back to grams. Let's see if I can make my thing any skinnier. Okay, 68.4%, 4 grams. Okay, in the second step, we took the grams and we changed it to moles. So we're going to take 68.4 grams, and to change it to moles, we're going to divide by its molar mass, or gram formula mass, of carbon, and we get that from our periodic tables, and I will show you that in a minute. Let me just get it written down so you can see. That 12.0 grams per mole, that is the mass of carbon. So right up here in the upper left-hand corner is the mass of carbon, so we're going to use that number to calculate moles. Let's get rid of that for a second. Hydrogen, we're going to do the same thing. We're going to take 13.9 grams. We're going to divide it by 1.0 grams per mole to figure out how many moles of hydrogen we have. And then finally we have oxygen, which is 21.6 grams divided by 16.0 grams per mole. We got these numbers, all of these numbers. Let's see. This number, and this number from our periodic table. Okay, now we just go back to doing math. I'll change the color to green just to keep things interesting. And when we do the math, we get 68.4 in our calculator first, and then we're going to hit the divide sign by 12, and when we do that, we're going to end up with 5.7 moles. And then this one's easy math, right? 13.9 divided by 1, so we get 13.9 moles. And then finally 21.6 divided by 16, so we have to look in our calculators and we get 1.4. Keep in mind I kept all of these to the nearest tenth. That's moles as well. That gives us our molar ratio. It gives us the molar ratio of carbon, which has a subscript or mole ratio of 5.7. Hydrogen has 13.9, and oxygen has a subscript of 1.4. Well, that's not the empirical formula, because by definition, empirical formula says that these numbers have to be lowest whole numbers. Not a whole number. Not a whole number. Not a whole number. So we have to make them into whole numbers, and that is where step 3 comes from. Step 3 says, alright, take these numbers, find the lowest one, and divide all 3 of them by that lowest number. So 5.7 divided by the lowest number that we have, which is 1.4, and we're going to end up with 4. And 13.9 divided by 1.4, and we're going to end up with 10. And then 1.4 divided by itself, that's a nice easy math, I like that one, is 1. So our empirical formula, I'll write it over here, we've got C4H10O1. That's the empirical formula. Again, I don't have to write this 1 there. It could just be understood that it's there. So you don't have to write the 1 in, but you can if you'd like to. Typically, we don't write in 1s as subscripts. Okay, so now we've got C4H10O, and that's our empirical formula. So that answered this part of the question, what is the empirical formula for the compound? But they give us some more information. They say the molecular weight for this compound is 148 grams per mole. Okay, and what is its molecular formula? Now, let's reach back and let's talk about molecular formulas. Molecular formulas are multiples of empirical formula. So our empirical formula, just so that we have it on this new page, is C4H10O. Okay, that's times 1. That would be C4H10O. Well, what is its mass? Its empirical mass, which is this one. This guy's the empirical formula. This empirical mass, we have to figure out what that is. So we've got 4 carbons. Where should I write? Let's see. Go right here. We've got 4 carbons, each weighing 12 grams per mole apiece. I'll write in my units because I always yell at you guys for not writing them in. So 4 times 12 is 48 grams per mole. We've got hydrogen. We've got 10 times 1.0 grams per mole. That's nice, easy math. I like that math. Grams per mole. And then we've got oxygen, which is one of them at 16.0 grams per mole. And again, nice, easy math, so we can just write that in, 16 grams per mole. Okay, when we add all of these numbers up, we get 74. So 48 plus 10 plus 16. If you don't believe me, here's the math for you. 48 plus 10 plus 16. 8 plus 6 is 14. 4 plus 5 plus 2 more is 74 grams per mole. So if we take the times 1, we can say its mass, its empirical mass, is 74 grams per mole. That's how much the empirical formula weighs. Let's get an eraser here so we have some room to work on. It never likes me to. Let's erase some of this. Not like the smart board where I can just circle it and hit the eraser. But beggars can't be choosy. Okay, so we've got times 1. Now we have to do times 2. If we multiply this by 2, instead of have 4 carbons, I would have 8 carbons. Instead of having 10 hydrogens, I would have 20 hydrogens. And instead of 1 oxygen, I would have 2 oxygens. It's doubling everything in the compound, because this multiple applies to the compound as well as the mass. So 74 is its mass. Well, if it doubled everything, 74 plus 74, or 74 times 2, is going to give me 148 grams per mole. Well, headquarters, looks like we have a winner, because we are looking for a molecular formula, here it is, molecular formula, for something that has a molar mass, or molecular weight, of 148. And this guy, right here, hopefully my pen doesn't die, because it seems to be dying when I change colors. That guy right there is a molecular formula with a molar mass of 148 grams per mole. So that's our answer for the second part of this question. Okay, we'll try one more.